Hello everybody. In this video we're going to show you how to do some kind of architecture in a C# application that include an application and an API. And the API will be responsible for handling some kind of controlling, for example, sensor temperature or some kind of hardware. So the project is actually divided into two. One, the type is Visual Basic, Visual C#. Okay. So technical, and we'll give it a name, for example, host hub. So we created a simple WinForm application. You see, we can run it, and then instead of putting all the logic inside the Windows form, we want to put the separate the project into two. One is an host application in exe file, and the other one is the API. So we can call it controller API, and this will be a class lib. Okay, let's name it like controller. You will change the name. So we have a class here, and we can make a default constructor. And what we need to do is to add a reference to this API. Okay, so now when we compile the project, we create a project that contains the controller DLL and the host application, and all the logic will be written here. In this application, we will write some kind of logic. First of all, let's create a thread, and we want to create a delegate callback. Okay, delegate is the possibility to send asynchronous messages from the API into the host. So public okay, we want to be able to initialize the callback from the host, and now we can compile it and go to our application, and okay, we can resolve it. We add the controller API here, and let's call it API, and now we can do like this. Okay. So I just prepare some kind of callback messages, and then we can initialize our constructor. And when we will, for example, send event in the controller, let's see, for example, public void start, public void stop. For example, if I want to send an event, let's write one and then started. Okay, so when the application will start, I'll get a message box saying what happened. So I can send status and any kind of information. To make it working, let's create two buttons. One is start and one is stop. We can call API start. See, it's very elegant. Okay, if I press start, then I get started. So now, instead of writing some kind of start here, I want to open a thread. Okay, so thread process start. Okay, we can do like this, like if thread, and then okay, if the thread is not started yet, we can start it and then create our process. Okay, here we do a while loop. We can do thread sleep of one second. And we initialize when the thread, we initialize the running. When we stop, set running equal to false. And we can do the following. While it's alive, we can do thread.sleep 10 milliseconds, and we can check that the thread will exit. Now, when the thread is exit, it's good time to send a callback, stopped, and we can put a label here. This will be our status, and we can say that instead of message box, we can say label one.text equal to message. One thing we need to do in C# Windows Form is to enable the application to call to controls in the thread. So we said check illegal cross thread. Of course, we do it false. In WPF, it's doing differently. So let's try our application. Let's do API stop. So this is some kind of infrastructure. Okay, and then we do stop, and our application didn't stop. Let's see why. Start is doing time, and stop. Okay, because so we send 0. Okay, so we do start and then stopped, and Okay. Okay, so what we need to do, and we need to do the invoke required in order to update the text inside the thread. Okay, so we do the name of the control, invoke required, and begin invoke. This is necessary to update it inside the thread. So now when I do a start and do stop, it stops within the thread and I get acknowledge. What else? Suppose my controller now will do inside the thread, it will say like some kind of check sensor, and I have check sensor, return I, return a temperature, for example, and we can do something like in temperature should be 20, and we can update the temperature callback. For example, let's do code 10, then to string. So now we can update the temperature in a different thread, in a different label. For example, let's do label 2, and we can call it temperature, and then label 3. So if we get case 10, we can do, we need to update label 3. Let's see. Okay, so now we're updating within the controller API, we're updating our application. So we separate the application and the host, and all the logic and all the if this controller is accessing hardware or something like this, we put all the logic here, and our application is now separated and getting asynchronous events from the application using the thread. You can stop it, and it will tell us this is stopped. So this is some kind of architecture that fit to many design. You create the thread, and you create a delegate inside the controller API, and this one can be, for example, you can create another class that is like a controller simulator. Okay, and the controller simulator can inherit from the controller, and the reason we are doing this is because, for example, if the controller is accessing real hardware and we don't have the real hardware, we want to access a simulation. And so what we can do, okay, we can override the check sensor, for example. Everything is the same. We can do protected virtual check sensor, and we can do override. The temperature should be protected because it should be belong to both parent and inherited classes. So now instead, for example, let's do like this one, will do plus equal to, and Now our application can be a controller API, new make it public. Okay, so now if we put a breakpoint, sorry about it, I did very fast. We have a controller, and now we want to do instance from the controller simulator. So this is the base class, this is the inherited. So MAPI now will do initialization from the controller simulator. And now, if we put a breakpoint here, we will see that now we are going to the different override function, and now it will increase by 2. So we can create a controller and controller simulator that have the same interface, and for example, this will be the function that do the simulation because you don't have the real hardware, and this function will read from the real hardware. And we have a separation here between the controller simulator and the application. And for example, if we have more hardware or more application, we can create more class libraries and add it to the project. So the idea is to make the application small. We don't want to put too much logic here, like API start, API stop, and other function can be here, but we don't want to put too many logic and too many code in the application. That's it for today, and thank you for listening. Sorry about the mess, because I did it on the fly very fast in order to make a real application written as I type. Thank you very much. Bye.